The movement inside Gigafactory Texas is drawing the attention of those who closely follow Tesla. The number of employees at the facility has practically doubled in a short period of time, jumping to around 23,000 workers by the end of 2023. But it's not just about industrial growth. Something bigger seems to be at play. The volume of hiring, the discrete infrastructure investments, and the tests that no one officially comments on indicate that Tesla is laying the groundwork for something strategic and perhaps revolutionary. Although Elon Musk hasn't confirmed anything, the buzz surrounding a new, more affordable model has never been higher. Among engineers, investors, and brand enthusiasts, the consensus is clear. Tesla is secretly preparing to launch the much-talked-about Model 2. And the reason for the secrecy isn't just its market impact. It's that this car could change everything. According to leaks and industry analysis, the vehicle is expected to cost an impressive $100 million, US $9,875, a practically unbelievable figure within the electric universe. And the most curious thing is that this number appears persistently in unofficial reports, as if it were a code everyone knows, but no one dares confirm. This price tag immediately triggers an impact on any consumer's mind. Is this serious? The idea of a Tesla car under $10,000 seems unrealistic, especially considering the competition's current prices. But if anyone could break this barrier and surprise the world once again, it's Musk's company. And all signs point to this turnaround happening in Texas. The factory isn't just growing, it's becoming the centerpiece of a new global strategy to popularize electric cars. What's happening inside is still shrouded in mystery. Warehouses have been expanded, areas have been cordoned off for testing, and Tesla's prototype tracks have never been busier. Some employees report unusual activity, with parts of covered vehicles being removed outside of normal business hours. For many, this is more than a coincidence. It's the typical quiet movement that precedes a big announcement. It's interesting to note that Tesla seems to be repeating an old formula that has worked before. Develop in secret, scale quickly, and only then announce. But there's a twist to this move. Unlike previous launches, the Model 2 would be the first explicitly aimed at mass market, a car designed to compete with popular combustion-powered models. In other words, Tesla no longer wants to simply lead the premium electric sector. It wants to dominate it from start to finish. Furthermore, investments in automation within the Gigafactory show that the company is optimistic about scaled production. Cutting-edge industrial robots are being integrated into assembly lines, and tests with new materials, lighter and cheaper, reinforce the idea that the focus now is reduce costs without sacrificing performance. All this so that the Model 2 is viable, profitable, and highly competitive. Another striking detail is Elon Musk's calculated silence. The CEO, known for revealing everything on X, formerly Twitter, has avoided speaking directly about the project. Instead, he drops enigmatic hints, such as, "The next leap will be accessible to everyone," or, "We're about to change the way the world views electric cars." This behavior only fuels speculation that the Model 2's launch is closer than it seems. And if the rumors are true, Tesla is about to unleash a wave of chaos on the automotive market. An electric car with cutting-edge technology, a modern design, and a budget-friendly price tag? It's the kind of proposition that could simply change the rules of the game. Gigafactory Texas, until now just a piece on the board, is about to become the epicenter of a revolution that could redefine the future of global mobility. If there's a well-kept secret behind the Model 2, it's hidden inside what they call the pancake motor. This curious name isn't just a cute nickname. It accurately describes the revolution taking place within Tesla's automotive engineering. The axial flux motor, unlike conventional cylindrical models, is thin, flat, and incredibly efficient. It takes up almost no space yet delivers power that, until recently, seemed like the stuff of a luxury sports car. The Model 2, born with the mission of affordability, is about to debut one of the most advanced technologies ever put into a mainstream car. The secret lies in how energy is converted into motion. While traditional motors use radial flux, with force rotating from the inside out, the axial motor works like two magnetic plates pressing against a disc. This creates a much larger active surface area to generate torque, that is, the force to move the car. And all this in a structure that appears as thin as a book. The reduction in size is not a design quirk. It directly impacts how the car will be built, how much it will cost, and how it will behave on the road. And we're not talking about small improvements. The axial flux motor can be 30% to 50% more efficient relative to its size and weight. Imagine a motor that weighs just 20 kg, yet delivers 250 kW of power, enough to make a lightweight car like the Model 2 zoom down the road with surprising agility. This combination of lightness and strength allows the vehicle to be faster, more agile, and even cheaper to produce. It sounds too good to be true, but that's exactly Tesla's plan. Another advantage is the freedom this engine gives engineers. Because it's more compact, it can be positioned in ways that would previously have been impossible. This opens up space for new mechanical and structural arrangements. The engine can be placed closer to the wheels, optimizing weight balance, improving traction, and even rethinking the suspension system. Every inch saved in the engine bay becomes an opportunity to innovate in other areas of the vehicle. Heat dissipation is another strong point. Conventional engines often suffer on long trips or during repeated acceleration due to the heat generated. Axial flux engines, on the other hand, distribute heat more evenly, preventing overheating and reducing the need for complex cooling systems. Fewer components, less weight, less maintenance, all in a more reliable package for the average driver. In the industrial aspect, the axial motor also shines. Because it has fewer moving parts and a simplified structure, it is faster and cheaper to manufacture. Experts point out that, with mass production, the cost of each motor could fall by up to 15%. This fits perfectly with the Model 2's proposition: to be the first truly affordable Tesla, without sacrificing the innovation that has always defined the brand. Savings at this point are essential to hitting the target price of $9,870. This type of technology, previously only seen in military projects, racing cars, or experimental prototypes, is now being prepared for everyday use. And that changes everything. A popular car with a state-of-the-art engine, ready to drive in any city, with above-average performance and a price below the competition. It's as if Tesla has discovered a missing piece in the electric mobility puzzle. The curious thing is that, by adopting this innovative engine, Tesla isn't just improving a car, it's proposing a new standard for the entire industry. Brands that want to compete in this segment will need to pursue similar technologies, or they'll be left behind. The Model 2, even before its official unveiling, is already influencing decisions within other automotive giants. It's a silent domino effect that began with a different, small, but extremely powerful engine. Now that the axial flux motor has demonstrated its power on paper, it's time to understand what it means in practice, and more specifically, on the road. Tesla's promise with the Model 2 isn't just about savings and innovation. It's about actual performance, noticeable in everyday driving. With this new engine, every acceleration, every turn, and even every kilometer driven will carry an efficiency almost impossible to imagine in a car of this price range. It's the kind of thing that makes even those who've never been interested in cars stop and take notice. One of the first impacts is on autonomy. With energy conversion efficiency between 96% and 98%, the axial flux motor makes better use of every drop of battery power. Compared to conventional motors, which average around 92% to 94%, this may seem like a small difference until you're driving. Over long distances, these few percentage points can mean a lot. Feed to 20 extra miles of range with the same charge. This completely changes the way drivers view range, especially in a city car designed for those still hesitant to switch from fuel to electricity. But it's not just range that improves. Engine response is another story. Because the magnetic path inside the axial flux is shorter and more direct, torque, the raw power that makes the car launch, arrives faster. This means more intense acceleration right from the start, especially at low speeds. For those driving in the city, at traffic lights or on hills, this difference is immediately noticeable. The Model 2 will launch quickly, with that grip that makes it feel like the car read your mind before you even put the pedal to the metal. Furthermore, this flatter engine structure helps reduce heat loss. Every time an engine gets too hot, it starts wasting energy, and also forces the cooling system to work harder. Axial flux, by better spreading heat, loses less energy and demands less from the cooling system. This means more battery power turns into real movement, and not wasted heat. And less heat also means more reliability over time, which is great for those who don't want the headache of maintenance. Another point worth highlighting is energy regeneration. When the driver brakes, the axial flux motor can recover the energy from the movement more precisely. This recovery can be up to 15% more efficient than previous engines, which, in practice, means more miles added to the range with each braking operation. For those driving in stop-and-go urban traffic, this feature is a hidden gold mine within the electrical system. Performance also translates into a smoother, more responsive ride. Power delivery is immediate and predictable, making the car more enjoyable to drive, without jerks or delays. For someone who might be buying their first electric car with the Model 2, this feeling of control and fluidity is essential. It's not enough to just be cheap. It has to be enjoyable to drive. And with this engine, Tesla hits exactly that mark. What's more, the axial motor also helps reduce noise and vibration. Fewer moving parts and a more stable structure mean less cabin noise and a quieter feel behind the wheel. Even though it's an affordable car, the Model 2 will be able to offer a driving experience reminiscent of much more expensive models. It's yet another advantage built into this technology that seems to have been tailor-made to surprise. Ultimately, all of this points to a shift in mindset. It's not just about putting a new engine in a cheap car. Tesla is delivering a set of smart solutions, which, together, elevate the electric driving experience to a new level, and do so without breaking the bank. With greater range, sharp acceleration, and less energy waste, the Model 2 is beginning to take shape as a machine that goes far beyond what you'd expect for this price. The way a car is designed influences everything, from performance to the feeling of spaciousness. And when a fundamental component like the engine completely changes shape, the impact on design is enormous. The axial flux motor, with its flat body and compact structure, allows for a quiet revolution in the way the Tesla Model 2 will be assembled. The car gains a new stance, lower, more aerodynamic, and with a clean look that conceals clever engineering. Tesla is using this opportunity to redefine not only what an electric car can do, but also what it should look like. The reduced height is the first detail that catches your eye. With less volume under the hood and floor, the Model 2 can sit closer to the ground, which not only improves its appearance, but significantly reduces air resistance. Simply lowering the body between 20 and 30 millimeters, you can now win 5% to 7% more autonomy, without changing the battery. It seems like a minor detail, but in a race for efficiency and range, these numbers make all the difference. And best of all, without compromising comfort or safety on the streets. The compact engine also opens up space where there were previously limitations. This means Tesla engineers have been able to reposition wheels, suspension, and other systems more intelligently. With the engine out of the way, the wheels can be pushed closer to the corners of the car, improving cornering stability and increasing cabin area. This gives the Model 2 a firmer, more secure ride, without needing to increase in exterior size. And since we're talking about interior space, it's worth highlighting what Tesla managed to free up inside the cabin. Without a bulky engine or complicated axles crossing the car, it was possible to create a completely flat floor from the front seat to the trunk. This completely transforms the feeling of space, even in a compact car. Rear seat passengers, for example, gain more footroom, and the interior as a whole becomes more functional and versatile. This design freedom is also reflected in the exterior. The absence of mechanical protrusions allows for cleaner, smoother exterior lines, without the bellies or bulges typical of cars that need to hide large components. The result? A sleeker car, with less aerodynamic drag and a more futuristic appearance, while maintaining compact dimensions. All of this combined helps the Model 2 appear more expensive than it actually is. Another subtle but important detail is the ease of entry. With the lowered body and the absence of raised engine platforms, the vehicle's entry height can be reduced to 30 millimeters. It may seem like a small thing, but in practice, it makes getting in and out of the vehicle much easier, especially for the elderly, children, or people carrying groceries. Small solutions like this show that Tesla is thinking about users' real-life experiences, not just graphics and technical specifications. Furthermore, a car with a lighter, more compact engine has a significant advantage in weight balance. By better distributing components between the front and rear, the center of gravity becomes more favorable. This improves handling in corners and under heavy braking, and also makes the car more predictable in the hands of the driver. It's a type of refinement typically found only in more expensive models, but which the Model 2 will deliver as standard. And finally, the simpler architecture allows for a cleaner, more efficient body structure. Fewer metal reinforcements to house the engine means less overall weight and more freedom to add safety and comfort. The Model 2 isn't just leveraging new engine technology. It's using that technology as a tool to completely reinvent your own structure, making every line of the car part of a carefully calculated equation. What makes the Model 2 even more intriguing is not only what it will offer consumers, but what it represents for Tesla as a manufacturer. Producing a high-performance car for under $10,000 requires more than good ideas. It requires sharp industrial engineering, clever solutions, and a motor that facilitates all of this. And that's where the axial flux shines once again. Its simple structure, with fewer parts and fewer mechanical complications, fits perfectly into Tesla's plan. Scale production without inflating costs. In this context, Gigafactory Texas becomes both a testing ground and a dream factory. Unlike traditional radial motors, which require long shafts, supports, bearings, and auxiliary components, axial flux has fewer moving parts, less friction, and less weight. This reduces the time and effort required to assemble it on the production line. Fewer parts mean fewer errors, less maintenance, and faster assembly of thousands of units per week. This manufacturing agility could be key to enabling the Model 2 on a large scale. Production costs are also directly impacted. Market analysts point out that an axial flux motor could come out 10% to 15% cheaper than its radial counterpart, even offering more performance. When multiplied by millions of units over the course of a year, the savings become a massive competitive advantage. This gives Tesla the opportunity to practice extremely aggressive pricing while still maintaining healthy profits, something no other player in the electric car market has managed to do so far with this level of onboard technology. Reliability also comes into play. Engines with less internal friction and better heat dissipation tend to last longer, require fewer overhauls, and experience fewer failures over the years. In other words, the car breaks down less, which is essential for a proposal aimed at a mass audience. It's not enough to just be cheap on the display. It has to remain cheap throughout its useful life.